High performance is not something you bolt on at the end of a project. It is built from the ground up and starts with how you plan and develop. It obviously depends on physical resources. You cannot perform well when you don't have sufficient memory to accomplish your task. But the physical hardware is only part of the story. How you plan and develop an application matters just as much, if not more. Here's a useful framing: mastering your tools gives you much better performance chances than just using them. Setting a high bar from the beginning of development forces more prudent planning. Some bad decisions at the database layer can really downgrade performance, and those decisions are very hard to undo once the application is in production. Cautious planning also causes developers to think more carefully about use cases and program more consciously. High performance is when you have to think about a new set of resources, processor, memory, storage, because all that you have is exhausted. Not just because one resource is running low. A high-performance application should not need a second server just because a little processor is busy and the disk is full. In that case, you just need a bigger disk. Applications can no longer be designed as monolithic systems. An increasing user base demands a distributed architecture, or at least one that can distribute load by having multiple instances. This is much easier to accommodate at the beginning of the planning phase than to retrofit into an application that is already in production. A distributed architecture also improves performance in another dimension. Geographically distributed servers can be physically closer to clients, reducing perceived latency. Databases distributed across more servers can handle more traffic as a whole and allow DevOps teams to achieve zero downtime goals. To know whether an application performs well or not under specific environments, you have to test it. This kind of test has a specific name, a benchmark. Benchmarking is important and it is specific to every application. Even for the same language and platform, different applications might perform differently either because of the way some parts of the application were structured, or because of how a database was designed. Analyzing performance will indicate the bottleneck of your application, the parts that perform worse than others. These are the parts that need to be improved. Constantly working to improve the worst performing parts will elevate the application's overall performance over time. There are 3 types of benchmark tests you need to understand. The first is load testing. Load testing is the simplest form. You test how the application performs under a specific load, how many connections it accepts per second, how many traffic bytes it can handle. A load can be measured externally, by looking at traffic, and internally, by looking at processor and memory usage. The second is soak testing. Soak testing runs the application under load for an extended period of time. It is done when an application tends to degrade over time, and the analysis tells you how and why it degrades. Soak tests are especially useful for detecting memory leaks, because some applications can perform well on short tests but slowly leak memory and degrade over hours or days. The third is spike testing. Spike testing increases load very rapidly to see how the application reacts and recovers. This is critical for applications that experience sudden spikes. Twitter during a breaking world event is a classic example. Operators need to know in advance how the infrastructure will handle sudden surges in traffic, not discover it live. V8 is an open-source Google project and is the JavaScript engine behind Node.js. It is responsible for compiling and executing JavaScript, as well as managing your application's memory needs. V8 is designed with performance in mind. It has a built-in profiler and one of the best and fastest garbage collectors that exist, which is one of the keys to its performance. Crucially, V8 does not compile JavaScript into bytecode first. It compiles directly into machine code on the first execution. This just-in-time compilation is why V8 is so fast compared to interpreted runtimes. But here's the catch: V8 optimizes code based on what it observes at runtime. It makes assumptions. If you violate those assumptions, V8 de-optimizes your code and falls back to a slower path. Understanding this is essential for writing Node.js code that stays in V8's fast lane. A good background in the V8 development environment greatly increases your chances of writing high-performance code. Here are the most important rules. First, write small functions. Small functions are more easily optimized by the JIT compiler. Large functions are harder for V8 to analyze and optimize. Second, use monomorphic parameters and variables. If a function always receives the same type, V8 can optimize it aggressively. If you pass a string sometimes and a number other times, V8 has to handle both cases and cannot specialize. Third, prefer arrays to manipulate data. Integer indexed elements are faster than object properties. Fourth, keep objects small and avoid long prototype chains. Longer prototype chains mean more lookups. Fifth, avoid cloning objects. Cloning large objects is expensive, the copy itself takes time, and the garbage collector has to clean up the original.